Lesson 22 is called the shape of data, so we're continuing in the statistics unit. So 22.1 is symmetry in data sets. So we're going to look at what makes a data set symmetric versus skewed. So a couple of vocab words for this section. The first one is the mean, which is the average of the data set. You calculate the mean by adding up all of the data values and then dividing the sum by the number of data values. So like you would add up all the numbers from your set and then you divide by like the quantity of numbers in your set. So if you have 10 different numbers, you would add them all up and divide by 10. And then the median is the middle of the data values. So in order to find the median, you'd put the data in order from least to greatest, and then you would just find the number that comes in the middle. If there are two in the middle, like that happens if you have an even amount of numbers in your data set. So if there's two middle numbers, then you find the mean or the average of those two numbers. So in that case, you would just add the two middle numbers and divide them by 2. Okay, moving down to the section that says symmetric data. So reading through this paragraph right here, it says if the shape of the data is symmetric, then the data in the display will look evenly distributed around the center. If there is a peak in the data, then both sides of the peak will look the same. This means that the mean and the median are the same. So when you have data that is distributed symmetrically, it means the mean and the median are the same. This is called a symmetric distribution. Okay, so looking at example 1, it says a farmer collected data on the heights in inches of 17 tomato plants in a vegetable garden as follows. So we have our data set, 15, 16, 16, 17, 17, 17. Looks like there are 1, 2, 3, 4, 5 18s, 3 19s, 2 20s, and a 21. And we want to find the mean and the median. And then down below, we're going to look at a couple of different data displays for this set. Okay, so if we want to find the mean, we have to go ahead and add all those numbers together. So just for the sake of saving a little bit of time on the video, I'm not going to show adding them all up together. But if we want to find the mean, we'd find the sum of all the data values. That means that you would do like 15 plus 16 plus 16 plus 17 and so on. You would literally add them all up one by one. Once you add all of these numbers up one by one, you would get 306. That would be your total sum. And then after you have your sum, you divide by the amount of like numbers within your set. So you can count up all these numbers, or it does tell us how many there are in like the original kind of description of the problem. It says a farmer collected data on the heights in inches of 17 tomato plants. So that must mean there's 17 numbers, but you can always count to double check. So we'll do 306 divided by 17, the amount of numbers that we added together. If you do 306 divided by 17, it ends up being 18. So 306 divided by 17 is 18. So that means that the mean of our data set is 18. And that means it's the average. Okay, and then to find the median, that means that we have to order the numbers from least to greatest, which fortunately this set is already listed from least to greatest. So that part's kind of already done, which is always nice. And then we just need to find the number that falls in the middle now. So to find the median, I like to just count down from each side and kind of put a mark under each number to show which one I've already counted until I get to that number in the middle. So we'll do 2 at a time, like one on the left side and one on the right side. And remember that they need to be in order from least to greatest before we start this. So 16 and 20 we can mark off, another 16 and 20. And then we just keep doing one on each side until we get to the middle number. And if there's more than one middle number, then we find the average of those two numbers. If you prefer, you can just cross off the numbers altogether. But sometimes that gets a little bit messy if you end up needing the numbers later. So I did 1 dot on the left side and 1 dot on the right side until I got to that middle number, which was 18. So that means that our median is 18. And notice with this data set, we had 17, which is an odd number of numbers, and we ended up having just one number in the middle, just that one median. We didn't have to like find the average of it or anything like that. So if you have an odd amount of numbers, you just get to find that one number in the middle like we did here. If you have an even amount of numbers, then you'll have to find the average to get the median. Okay, so we ended up with a median of 18 also. So we talked about up here that If you have a symmetric distribution, then the mean and the median are the same. And in this problem, we got that the mean and the median were both 18. And so that means that our distribution is going to be symmetric. So we can look at a few different visuals of a symmetric distribution here. They kind of are like with a butterfly, like butterfly's wings are symmetric on each side. You can think of a symmetric distribution kind of the same way. So like if I were to, I could like draw a line down the middle of this first one, the histogram, and it's symmetric on either side. So an example of a symmetric distribution, again, that happens when the mean and the median are the same. This is that data set just put as a histogram, and then in the middle is that same data set as a dot plot, and then you'll see again it's symmetric like right through the middle, and again the mean and median are the same, those go hand in hand. And then on the far right side we have a box plot. So you can see on the box plot as well, it's symmetric on either side if we were to draw a line down the middle. So that'll always be the case when you have a symmetric distribution. And then I know I've said it a bunch of times, but hopefully the more I say it, the more easy it is to remember. Symmetric distribution happens when the mean and median are the same. Okay, so moving down to our skewed data example. So this is example 2. The farmer also records the heights in inches of 18 pepper plants as follows. We want to find the mean and the median again. Okay, so for finding the mean, we would add up all of these numbers right here. So 15 plus 16 plus 17 plus 18 and so on plus 19, everything. Again, I'm going to leave that off the video just for a little bit, save a little bit of time. But we're going to add up all of those data values. So the sum of the data values is 382. And then we're going to divide that by the number of data values, or like the quantity of data values, which in this case is 18 because there's 18 pepper plants. So 382 divided by 18, I'm actually going to write this down below, ends up being 21.2. So the mean of this data set is 21.2. And then if we want to find the median, we need to make sure that the numbers are listed from least to greatest, and then we'll go down and find the middle of the data set. So it's already listed from least to greatest, so I'm just going to kind of treat it the same way as I did before, where I mark one number on each side until I get to the middle. Okay, so I marked one number on each side, and if I do it one more time, then I'm going to have no numbers left over. So those two numbers, 22 and 23, those are in the middle. So those together I have to find, sorry, I keep making that noise, I bumped my watch. So I have to find the average of those two numbers in the middle, the 22 and the 23. So to find the average, so we'll say median, equals, and then to find the average of 22 and 23, we do 22 plus 23 divided by 2. It's just like finding the mean of those two numbers. If you recognize that 22.5 is in the middle of 22 and 23, that's fine, but sometimes it's a little bit harder to find that middle number. So 22 plus 23 is 45 divided by 2. And then if we do 45 divided by 2, that's 22.5. So the median is 22.5. So this time our median was not the same as our mean. Our mean was 21.2 and our median was 22.5, which I know they're close, but they're not the same. So if they're not the same, then our data is not going to be symmetric. And you can see that on our graph. Like if our data is symmetric, then that means that if I draw a line through the middle of it, it should be kind of a reflection of itself on either way. And you can see that on our data set, there's at least on this dot plot, there's a lot more dots on that right side. So this would technically be a skewed left data set. I know that seems weird, so hang tight. So this is an example of a skewed left data set. And that happens when the median is larger than the mean, or the mean is less than the median. We'll talk more about what each skewed left, skewed right looks like in the next section. So I know it seems kind of weird because everything's on the right there, but I promise it's skewed left. Okay, so 22.2, this is about skewed data sets, just a little tiny section. So starting in that first part, when the mean and the median are the same, the data set is symmetric. So we talked about that at the very beginning of 22.1. If the mean and the median are the exact same number, then that means that the data set is symmetric, meaning I could draw a vertical line down the middle and it would be like a reflection of itself on either side. In the second box, I'm actually just going to kind of highlight that the mean and median are the same is what causes it to be symmetric, just so we have a little bit less highlighting going on. We can focus on the key points. So mean and median are the same. That's going to be what makes it symmetric. And then when the mean is greater than the median, the data is skewed right. So this is an example of a graph that's skewed right. And then on the little like last box, when the mean is less than the median, the data is skewed left. So for me, like when I look at the graphs for skewed left and skewed right, they feel like they're backwards. So one thing that I kind of suggest in thinking about it, and if you have other ways to help you, you should share them because it's always kind of confusing. So I like to think of like the data sets as like a slide almost. So if I were to like slide down this data set, I would be sliding to the right. So it's skewed right. Or if I were to slide down this data set, it slides to the left. So this would be skewed left. So that's one trick. If you think of other tricks, I'm all ears, share them with the class so we just have like more ways to help us remember. Okay, moving down to 22.3, this one is creating box plots. So box plot is made up of 5 data values. There's the minimum, which is the lowest value from the whole data set. There's the first quartile, which is the middle number from the lower half of the data. The median, which is the middle number from the whole data set. The third quartile, which is the middle number from the upper half of the data set. And then the maximum, which is the largest value from the entire data set. So example 1, make a box plot to represent the following situation. This example, just for your notes for you to refer back to, is going to be like when we have an odd amount of data values, and then example 2 will be when we have an even amount of data values. Okay, so a teacher records math test grades for a class of 15 students as follows. We have 68, 75, 75, 78, and so on. We need to go through and find like all 5 of these values before we can really even begin our box plot. So there's I guess there's not a set order that you have to go in. I would probably recommend just finding like the minimum and the maximum first. So I'm going to add maybe like suggested order here. So I would find the minimum and then find the maximum. And then I'm going to find the median, and then I'm going to find the first quartile, and then I'm going to find the third quartile last. I know it's probably like, well, why didn't you just like list them in that order? But you'll see like once we actually get our values, having minimum, first quartile, median is actually going to like kind of translate a little bit better to like once we go to create our plot. Okay, so let's see, the minimum. That's the like smallest value of our entire data set. So our data set is already in order from least to greatest, but if it wasn't, you would want to put it from least to greatest, the smallest number to the biggest number. So our minimum is 68. And then the maximum, that's the highest number in the entire data set. So that's 100. And then the median, that's going to be the number in the middle of the entire data set. So I'm going to do it the same way as I have been, where I just kind of mark down with dots each value until I get to the middle. Okay, so I marked one down on each side until I got to the middle, which was 85. So our median is 85. And then our first quartile and third quartile, those are going to be like kind of half of like half. So if we want to find our first quartile, that's going to be like the halfway point of the first half of the data set. So I'm going to erase some of these dots. So for the first half of the data set, we're looking at everything before the median. So we're looking like out of just all of these points right here. And then I'll kind of use the same dot strategy. So one on like the lower end, one on the upper end until I get to the middle, which is right here at 78. So for the first quartile, you're looking at like all the numbers before the median, not including the median. So the number like in the middle of all those numbers is 78. So my first quartile would be 78. And then for my third quartile, we're looking at all the numbers on the like upper half of the data set after the median and like not including the median. So we're going from 88 to 100. So we'll do one on each side. And the one in the middle would end up being 94. So my third quartile is 94. So those are all the numbers that I need to kind of create my graph now. So what I'm going to do is I'm going to put, or my box plot, I'm going to put a point above each number that I have in my like these 5 important numbers on my, or above my axis. Okay, sorry. So we have 68, 78, 85, 94, and 100. I'm going to put all those points on there. So 68 is right here, and I'm not going to put the points like directly on the axis. I'm going to put them a little bit above. And then 78 is right there. 85, this is by 2, so 85 is going to be like halfway in between 84 and 86. And then 94, and then 100. And then the middle 3 points are going to get a vertical line through them. Like this. Sorry, those are kind of off center. But the middle 3 points get a line through them. The like outside points do not. And then those like 3 lines, we're going to form a rectangle from them. So we'll just connect them all with a horizontal line to form a rectangle. And then the last step is to just connect that rectangle to those 2 points on the far left and on the far right. Okay, so this is what the shape should look like. You should have a rectangle with a line in the middle of it, and then you should have 2 points that kind of extend out from the rectangle. I'm gonna scroll up really quick to like the first section that we did, just so we can see kind of an example of one that was completed. So you can see this is an example of a box plot. It looks kind of almost the same general shape. It's skewed differently than ours was, but it has a rectangle with a line through it and then 2 points that extend out. And then I'm just gonna go through and label each of our like 5 values on here. So this first point is the minimum. I'm just gonna shorten it to min. And then this far right point, that's our maximum. Just gonna shorten it to max. And then the like first part of the box right there, that's our first quartile. I'm gonna just do first Q. And then the like middle line in our box, that's the median. And then the last line in our box, like the end of the rectangle, that's our third quartile. So I'm just going to do third Q for third quartile. And then it'll be arranged that same way every single time. The only thing that'll vary is like what our actual numbers are for like the minimum, maximum, quartiles, and the median. Okay, so example 1, this is our last one. It says make a box plot to represent the following situation again. Suppose the same teacher now records the test scores for his other 20 math students as follows. So this time we have an example of when you have an even data set, so it'll look a little bit different. I would make sure to kind of differentiate between the two in your notes, because definitely like even kind of adds like a little bit extra layer of difficulty. So we have our data set, which is 68, 70, 74, 75, and so on. We want to go through and find minimum, first quartile, median, third quartile, and maximum. So the minimum, that's the like smallest number in the entire data set. So the smallest number in this data set is 68. I'm going to find the maximum next. That's the largest number in the whole data set, which is 100. And then for the median, I'm going to find, just kind of put a dot on each side until I get down to the middle. This one has an even amount of numbers, so I'm going to end up with 2 numbers in the middle, and I'll have to find the average of those 2. Okay, so I ended up with these 2 in the middle right here. So 85 and 87. So the median is going to be the average of those 2. Average just means like the halfway point between the two. So if you don't have to use like a formula or anything like that, you don't need to. So like 85 and 87, the middle of those two is 86. So the median is going to be 86 because that would be like perfectly in the middle of those two. If you ever can't tell what number would be in the middle of those two, you add them together, you do 85 plus 87, and you divide it by 2, and then that would give you 86 also. So the median is 86. And then if I want to find the first quartile, that's going to be the like median or middle of the first half of numbers, the lower half. In this case, since there was like two medians, not two medians, but there's two numbers in the middle, that number does get included with the lower half. So that 85 would get included with the lower half, and then the 87 would get included with the upper half when you're finding the quartiles. So we'll mark off one on each side. So again, I ended up with 2 in the middle here. So I have to find like the average of those two. The average of 75 and 76 would be 75.5. So that's going to be our first quartile. So 75.5. And then for the third quartile, that's the median from the upper half of the data set. So the section that I have underlined in red right now. And again, like when you have two numbers in the middle, those numbers, like you break the data set like down the middle, separating them, and you count them when you're finding the quartiles. You don't just like leave them off like we did when there was an odd amount. So I'll make 1 point on each side until I get to my middle value or values for this upper half. So again, I have two numbers in the middle. I need to find the like average of those two numbers. So 95 and 96. The average of those two would be 95.5, or if you're not sure, you would add them together and divide by 2. So the third quartile is going to be 95.5. So we have all of our numbers. Now we can just go ahead and put the points and begin to create our box plot. So the minimum is 68, so I'll put a point above 68. The first quartile is 75.5, which is going to be a little bit less than 76. So it doesn't have to be perfect, just make it as close as you can. And then the median is 86, so we'll put a point above 86. The third quartile is 95.5, so that'll be a little bit less than 96. And then the maximum is 100. And then we draw little vertical lines through the middle 3 points. So every point besides the like exterior 2, I guess, or like the far left and far right. And then from those 3 lines, we're going to have to form a rectangle. So we'll draw some horizontal lines connecting all those to create our rectangle. And then from our rectangle, we will extend out to reach our other 2 points. So we'll extend out here to the minimum, and then out here to the maximum. And then I'm just going to go through and label each part one more time. It's just good to get comfortable with where each part is. So the very far left, that's the minimum. And then the very far right, that's the maximum. And then the first line of the rectangle, like the furthest leftmost, that's the first quartile. So I'm just going to do first Q. And then the middle line of the rectangle, that's the median. And then the last line of the rectangle, that's the third quartile. So I'm just going to do third Q. And then you can see we have another box plot completed. It's structured the same as our like first example. It just looks a little bit different because we had different data sets in there.